Okay guys, welcome back. We're in 7.2.2. We're talking about coordinate geometry. We've got a number of different things to cover in this video, so let's get started. So first off, coordinate geometry is the study of geometry on the coordinate plane. Using common algebraic and geometric tools, you can learn more about a polygon, such as does it have a right angle, or are there two sides with the same length? One useful tool is the Pythagorean theorem. Remember that the Pythagorean theorem states that a squared plus b squared equals c squared, where c is your hypotenuse of the right triangle and a and b are legs of the right triangle. So, for example, the Pythagorean theorem could be used to determine the length of side AB of quadrilateral ABCD at the right by drawing a slope triangle between points A and B. So let's do that right now. So if we draw a triangle, perhaps a smaller triangle than that, we should be able to use that to help us find the length of that side. So that triangle is now lined up. We can see that the bottom has a length of 2. This top edge has a length of 5, which I can get by counting 1, 2, 3, 4, 5. And then so the c squared is going to actually be that length AB. So I can just plug that into my Pythagorean theorem and figure out that AB is equal to the square root of 29 units. Square root of 29 is going to be somewhere between 5 and 6, because the square root of 25 is equal to 5 and the square root of 36 is equal to 6. The square root of 29 is right in the middle. So we're going to be somewhere in the 5.4, 5.5 range for that value. In general, we can label the coordinates of any 2 points, x1, y1, and x2, y2. The slope triangle between these points have side lengths of x1 minus x2. Notice that's an absolute value. That means that if you come up with a negative, you need to make it a positive, because the lengths of sides are never negative. They're always positive. Thus, the distance between any 2 points, x1 and y1 and x2, y2, can be found using the Pythagorean theorem, written as what we call the distance formula. So this distance formula is actually just a rewriting of the Pythagorean theorem. If we take x1 minus x2, if we subtract the two x values, we get the bottom of the triangle. We get the horizontal part. If we subtract the two y values, we get the vertical part of the triangle. So in our example case, that would be 2 and 5. We take the square root of that. We get the distance, which would be 2 squared, which is 4, plus 25. That's the square root of 29, which is what we got right here. So the distance formula is just a reworking of the Pythagorean theorem. So if you know Pythagorean theorem and you can figure it out on the coordinate plane, then the distance formula flows right from that. So distance formula. You do probably want to go ahead and write it down, though, if you don't have it written down already. Similarly, slope can help analyze the relationship between the sides of a shape. If the slopes of two sides of a shape are equal, then those slopes are parallel. For example, since the slope of BC, going back up here, is equal to 2 over 5, and the slope of AD is equal to 2 over 5, then BC and AD are parallel. So if we were to pick a point here and go, I'm going to erase my slope triangle there, and we were to go up 2 over 5, up 2 over 1, 2, 3, 4, 5. You can see that would get us to another point, and then up 2 over 5 would get us to another point here. These have the same slope, so they are parallel. So buried in there is the definition of parallel, which are just two lines with the same slope. All right. Also, if the slope of two sides of a shape are opposite reciprocals, then the sides are perpendicular, meaning they form a right angle. So if we flip the fraction and change the sign, we get the perpendicular slope. So the slope of the line perpendicular to BC would be 5 over 2, and we would change the sign from positive to negative, so negative 5 over 2. So opposite reciprocals equal perpendicular slopes. And we already saw that this slope had to be 5 over 2 because that was the 2 and 5 we used in our Pythagorean theorem. BC has a positive slope because it goes up and to the right. And AB has a negative slope because it goes down and to the right. So as you're reading from left and right, if it goes down, it's negative. If it goes up, it's positive. Okay, by using multiple algebraic and geometric tools, you can identify shapes. For example, further analysis of the sides and angles of ABCD above show that AB equals DC and BC equals AD. Furthermore, all angles are right angles. These facts together indicate that ABCD must be a rectangle. So because opposite sides are congruent and all the angles are right angles, this shape must be a rectangle, which is not immediately, can't be 100% sure of until we test it out. All right, so giving you another one here to work on. We have a little parallelogram, PQRS. I want you to find the length of PQ, of QR, find the length of RS, find the slope of PS, and then find the slope of PQ. Have a good one, guys. I'll see you next time.